this function, we kind of mentioned like graphing lines, right? During the process of this last example, let's mention, oh, that's a line of slope of 1, that's a line of slope negative 1. So we have some of these words, let's just formalize them. So let's start with this. A linear function, for me, will be any function which can be put into the form f of x equal to mx plus b. This form, as we'll say at the bottom, is sometimes called the standard form for a line, or the slope-intercept form for that line. But fundamentally, what's a linear equation? It's an equation whose form looks like that, at least after some algebra. So let's just go ahead and do some identifying. 9/5 x plus 32, is that a linear equation? Cool. That means it should be able to be put in that form with a choice of m and a choice of b. What are m and b?
M is 9/5.
M is 9/5. B.
32.
Nice. Ooh. And another set of words that are important here is what types of things are m and b allowed to be? They have to be constants. So the next one, g of x equal to x times x plus 1. Is that a linear function? See some heads shaking no. Why not?
Because it simplifies x squared plus 1.
Yeah, it becomes like an x squared plus 1. So you know that its graph isn't going to be a line, so that's a problem. I guess ultimately it comes down to, if you want to try to put it in this form, you would want that to be m, but that's not constant. So that is not a linear function. H of x equal to 3, is that a linear function? Folks who want to say yes? Folks who want to say no? Well, I feel like this vote was decided by the people who decided not to vote. Which, you know, fair enough. Those of you who said yes, I agree, it is linear. And in fact, what is m and what is b?
M is equal to 0, B is equal to 3.
M is equal to 0, b is equal to 3. Yeah, because this happens to be the same thing as 0 times x plus 3. So there's your m, there's your b. So importantly, a linear function isn't a function that already has the form y equals mx plus b. It just has to be able to be put in that form. In this case, you could stick that plus 0x because adding 0 doesn't do anything. This final example, is it a linear function? Let people stare at it for a bit. Folks for yes? Folks for no? Cool, I agree, it is linear. That means you should be able to put it in the form y equals mx plus b. Take a moment and do the algebra to do that. And once you do, tell me m and b. Cool. Folks feel happy? So what is that?
2.
I hear a 2. Do I hear a differing answer from 2?
That would be 4.
Oh, okay, no, it is 2. Yeah, I'm happy with 2. I wasn't looking at the numbers, I had forgotten what one of them was. I do hear some controversy though, 4. So we'll go through some algebra and find it. What about B? What'd you get for B?
4.
I also hear a 4. let's go through the walk and find it. So, to figure out the m and b, I need to get this into a form where the actual function name, so y, is on its own. And the rest of it needs to have the form mx plus b. So let's just do the algebra to get y on its own and see what the rest of this thing is. So you want to get y on its own, what should you do to this thing first? Right here and add 3. So 2y minus 3 equals 4x plus 5. Let's add 3 to both sides. So 2y equals 4x plus 8. Okay. You want to get y on its own, so what do you do next? Divide by 2. And I think I'm going to demo doing something wrong here. I'm going to divide both sides by 2. I'm going to do it wrong, and you'll tell me what I did wrong. So what does divide by 2 mean? It means multiply by a half. So let's multiply by a half. 4 divided by 2 will give me 2. So y equals 2x plus 8. What did I do wrong?
Divide the 8.
Yeah, you need to divide everything on both sides by 2. So if you like, you need parentheses. And I'm demoing it here because this is a really common error that I just see on homeworks and stuff, and it's an easy mistake to make. Basically, you just need to remember those parentheses. So, you need to remember to divide that 8 by 2 as well. So yeah, here's my m is 2, there's my b is 4. Feel pretty okay? Alright. This form of line, as I said, is the so-called standard form. It's the simplest form you can put most linear functions into. It's also called the slope-intercept form, for a reason that we will explore in a moment. And these linear functions are called linear for a good reason. And in order to see that reason, let's go over here to the side. So off to the side are the exact same equations that you classified as linear or nonlinear. And they've been graphed. So this first one we decided was linear. Second one, not linear. Third, linear. Fourth, linear. So just by looking at those, like, what's common to the graphs of linear functions? Yeah, their graphs are straight lines. Maybe they have some slope. Maybe their slope is 0. Linear functions are just called linear because they're graphs are lines. So lines have like a property called the slope. Lines have a slope. It's just how far up do you go when you go over some amount. Let's talk about that slope. So if you have 2 points on a line, how do you compute the slope of a line? What is the slope?
Y over x.
Almost. I'm going to throw a change in y divided by change in x. And I'm going to write this in a handful of different ways. Especially once you start doing some calculus, you'll see the Greek letter capital delta indicated for change an awful lot. The only reason for that is because the word differential or difference is assigned the letter D, and the Greek letter delta is like kind of like a D. Mathematicians don't actually know Greek. Maybe you'll see it also written as rise over on. But ultimately the formula is just how much does the y coordinate change divided by how much does the x coordinate change. That feel pretty good? You want the slope of a line? If you pick any 2 points on that line, compute the rise over on using those points, you get yourself a slope. So let's use that for something. let's compute the slope. Oh, let's change colors again so we can tell what the problem is. Let's compute the slope of 3y equals 2x minus 4. And like, I have a plan that I want to do. I want to like pick 2 points on this line and use those 2 points to find the slope. How many people like just have already computed the slope of that using some different technique? What'd you get? 2/3. I think I agree. Hold on to that though. We'll explain that idea in the next line. So let's compute the slope of this line by actually checking some points. So that means I need to like take this x value, figure out what y value it corresponds to. Take this x value, figure out what y value it corresponds to, and then use those 2 points. So when you take x equals 0 and plug it into this formula, what do you get for y? Let's see, maybe I'll do the algebra off in the margins. We'll see what we get. So we'll get like 3y equals 2 times 0 minus 4. The 2 times 0 doesn't matter. 3y equals minus 4. So how do you solve that for y? Alright, like you just divide by 3. So negative 4 over 3 is the y value that corresponds to x equals 0. When x equals 1, what y value do you get? I hear a negative 2/3. Do I hear a second? Cool. All right. Well, let's use those. So that means the slope is the change in the y value. So it doesn't matter which one I subtract first, but I just need to be consistent. So negative 2 over 3 minus negative 4 over 3 all over x value that corresponds to 2/3 is 1 minus 0. And now it's just like a simplifying game, right? And I don't know. How do people feel about simplifying fractions? Anyone want me to do it myself? Cool. Let's do that. So, whenever you're simplifying in general, just look at it one piece at a time. So I see some complicated stuff in the numerator. I see some stuff in the denominator. What is that denominator equal to? Just 1. So let's replace that whole denominator with 1 in this step. Oh, cool. So I even know what I'll do next. Division by 1 doesn't do anything. I see minus a negative, so it's the same as addition. And here's the thing to think about whenever you add or subtract fractions. If their denominators are the same, then you just need to add the numerators. Right, like 5 halves plus 7 halves is 5 plus 7 halves. These already have the same denominator, so adding fractions is easy. We just need to add the numerators. So I can add these numerators, and I will get parentheses negative 2 plus 4 over 3. So far so good? At least feel familiar? And now let's just keep simplifying. Tell me what you would want to do to that next to simplify. Yeah, I guess it'd just be 2 over 30, right? The big divide by 1, who cares? cares about that? So it's something divided by 3. Let's put the over 3. Negative 2 plus 4 is 4 minus 2. That's 2. So 2 thirds is the slope of this line. So those of you who just said in advance that this slope is going to be 2 thirds, what did you do to get that 2 thirds? Okay. So here's the fact about slope-intercept form. It tells you the slope. If you see a line in the form y equals mx plus b, let's just see. What is the slope of a line if you already have it in that form? Yeah. This parameter m tells you the slope. This is why it's called slope-intercept form. The constants m and b give you the slope and the y-intercept. So let's use that. Let's again compute the slope of this line by just trying to put it in that form. So you see this line, it looks like to put it in the form y equals mx plus b, I just need to get y on its own. So what should I do to get y on its own? Divide by 3. So y is equal to, I need to divide everything on the right-hand side by 3. So 2x minus 4 over 3. I don't quite have it in this form yet. Right? I see like 2x minus 4 all over 3. Division distributes over subtraction. So I just need to divide each of those ingredients by 3. 2 thirds x minus 4 over 3. Oh, cool. So now that we've done that, what's the slope? 2 over 3. Nice. Folks feel okay about this? Nice. All right. So, basically what I'm going to do with most of today is just mess around with what various equations for lines can be used to tell you. And here's the next one that I want to hit. So if I give you 2 points on a line, is that enough information that you should be able to just know what the line is? Like, geometrically, that seems sensible, right? If you happen to know that 1, 3 is on this line, and 3, 2 is on this line, then like, there's only one line between those 2 points. It's that. So you know what line this is. That means you should be able to find an equation for it. And here's the type of equation I will suggest. An equation for a line in point-slope form. The point-slope form for a linear equation is y minus y0 is equal to m times x minus x0, where m is the slope. And x0, y0 is a point on the line. Let's try to use that in this case. So to use this form, I need a point on the line and I need the slope. Do I already know a point on the line? Yeah, in fact, I have 2 different points. I can pick which one I use. Which one would you rather use? Do you think it'll make a difference? So, I don't know. Maybe here's there is space on the next page, but I'd rather have everything on this page. I'll use x0, y0 equal to 1, 3. If you have an independent mindset on this, use the other point. See if you get the same end result. To do something in point slope form, I need to find the slope. Is it easy to find the slope of this line? Or at least do I have enough information? Yeah, cool. So let's compute the slope. M equals slope is change in y over change in x. So we can compute that. Let's see, change in y is 2 minus 3 over 2 corresponds with an x coordinate of 3. 3 minus 1. Is that negative a half? I think that's negative a half. All right. So we know the slope. The slope is negative 1/2. Is that enough information that we can just put this in point slope form now? Yeah, let's do it. Y minus y0 is equal to slope, negative 1/2, times x minus x0. That feel pretty okay? What if I wanted this also in slope-intercept form? So I wanted just y on its own. What would you need to do? Yeah, subtract that 3 to the other side. Maybe also distribute that 1/2. So I just want the m next to the x. That's not so hard to do. We can do that. That'll give me y equals, distribute the 1/2, negative 1/2 rather, negative 1/2 x plus 1/2 plus 3. So y equals, oh, this is slope intercept. So this is y is negative 1/2 x plus 3 plus a half. Should we put that as a fraction or as a decimal? Which would you rather? Fraction? Decimal. Cool. If you want the decimal, that's 3.5. If you want the fraction, it's 7/2, right? Cool. Folks feel pretty good? How many people in the meantime did that using the point 32 instead? Okay. So if this actually all works out, that point should give us the exact same line, right? Do you think it's worth the effort of making that check that if we use the other point we get the same line? Is there demand? Okay, cool. Then I will say this. Exercise. Use x0, y0 equal to the other point, 32. Do you get the same slope intercept form? Cool. All right, any questions about what we've done so far? All right, so let's keep plugging along. In general, let's suppose I give you 2 points sitting on a line. Was there anything special about the 2 points that I gave you here? Nah. If you want to find an equation for a line, what do you need to do? Find the slope. Put the thing in point slope form. And finally, if you want to, put the thing in slope intercept form. Cool. All right. So let's do something that's going to wax pretty, well, very applied. This is like a relevant formula that's worth knowing. The two popular units for measure of temperature by people who aren't working in a scientific setting are the Fahrenheit or Celsius. If you're working in the sciences, probably Kelvin is relevant. But for the sake of this example, let's talk about Fahrenheit and Celsius. So, let's try to get the conversion between Fahrenheit and Celsius. Here's the fact that the conversion from Fahrenheit to Celsius is a linear function. And that makes sense, right? If it changes some amount in Fahrenheit, it's going to change some amount in Celsius. And all that matters is how much they each changed. If you want to know how much one changes, you just need to know how much the other changes. Yes, that sounds like there's like a constant slope. So, let's try to figure out that formula. And so basically we just need to know two facts about Fahrenheit and Celsius. That'll let us convert between them, and here's something reasonable that you should just like know, right? What's the temperature at which water freezes?
32
In which units?
Fahrenheit.
32 Fahrenheit. And what is it in Celsius? So that means that 0 Celsius is 32 Fahrenheit. At what temperature does water boil?
100 degrees Celsius.
100 Celsius? What about Fahrenheit? Yeah, that's right, right? Okay. It's pretty sure I was remembering, but then like everyone gave me a blank stare instead of confirmation. That made me scared. Good. That means I don't have to go and like double check myself by looking it up. All right, so let's use this to find a formula for this conversion. And maybe I'll ask you this first. Would you rather have a formula that converts from Fahrenheit to Celsius or Celsius to Fahrenheit? From Fahrenheit to Celsius. I see one. The other way around, from Celsius to Fahrenheit. Well, okay, cool. So that means I'm going to have the mindset of let's treat Celsius like the input value, the x value. Fahrenheit is the output value, or y value. So if I want to go from Celsius to Fahrenheit, oh gosh, and Fahrenheit's a strange name to spell. That means I want to treat Celsius as the x value, Fahrenheit as the y value. I would like to get the actual formula for this conversion. I know it's going to be a line. So that means I want to know an equation for a line that goes between these points. So let's just label these points. So 0 Celsius corresponds to 32 Fahrenheit. I'm not going to worry about having a reasonable scale. 100 Celsius is 212 Fahrenheit. So I want an equation for the line that goes between those 2 points. And now I guess I'll see how people want to do this. Do you have everything you need to be able to find an equation for that line? It looks like some of these numbers are big, so maybe you want to use a calculator. You certainly don't need to do this. Yeah, sure. So now, ultimate check. Do people want me to say more about this example before I cut you loose? Awesome, do it. I guess follow the steps above. just consistent. Oops. Cool. Let's come together. What's the slope?
1.8.
And you're on 1.8? Anyone get that as a fraction instead of a decimal? What'd you get? 9/5 or 1.8. Would we rather decimals or fractions?
Fractions.
Cool. And I asked that as a question intentionally because, like, they're both totally reasonable. Either the slope is 1.8, meaning for every 1 Celsius degree the temperature increases, the Fahrenheit temperature increases by 1.8. Or for every 5 you increase in Celsius, you are by 9 in Fahrenheit. So when you put this in point slope form, what'd you get?
9/5 Celsius plus 32.
9/5 times the temperature in Celsius, which I'm going to use as x just in order to match up with the picture. Eventually I'll want to say Celsius instead, but for now x. Plus 32 equals what?
Fahrenheit.
Fahrenheit, which I'll call y. So I guess that means you used... No, okay, so that's your final answer.
No.
Yeah, one of like the intermediate steps too. You're good. So how many people did proceed by putting it in point slope form and then from there going to slope intercept? Cool. What'd you get in point slope form?
Y minus 212 equals 1.8x minus 180.
And that was after you like distributed that multiplication over the parentheses too. Because you said 180 instead of 100. So.
Yeah, okay, yeah.
Point slope form has the parentheses, so I'll leave them there. How many people use the other point instead? So if you do, you should get something that's equivalent. In which case you'll get y minus 42 is still 1.8 or 9/5 x minus 0. Between the pink or the blue, which one do you think would have been easier to do the algebra with? Pink. So both of them are perfectly valid. They both lead you to the right answer. That one has smaller numbers. Neato. Folks feel pretty good about this? So what's the end payoff? Since x is temperature in Celsius, y is temperature in Fahrenheit, that tells me temperature in Fahrenheit is 9/5 the temperature in Celsius plus 42. Groovy. So, you find yourself in a situation where you want to convert temperature Celsius to temperature Fahrenheit, multiply by about 2, then add 42. Groovy. Let's carry on. So the next thing I want to hit, so y equals mx plus b. This is called the slope-intercept form. And we've seen that it tells you the slope automatically. The slope is that m. Since it's slope-intercept form, it should also tell you m-intercept. And let's just try to see that it tells you an intercept and how to read off an intercept. And to do that, let's remember how you get the x and y intercepts. How do you get the x-intercept of an equation?
Set y equal to 0.
Set y to 0. And if you're like playing too fast and loose, you'll say, I want the x-intercept, I'll set x to 0, which will give you exactly the wrong thing. So the x-intercept, you get it by setting y equal to 0, solving for x. And that's because it is where the graph hits the x-axis. Similarly, the y-intercept is where the graph hits the y-axis. And so you get that by setting x equal to 0. So let's just do a quick example. 3x plus 4. Find for me the x-intercept and the y-intercept of this thing. And again, like, I'll do as much work as you want me to do. If you remember the notions, then it's better to get practice with them on your own. But if you want me to talk through it, I'm fine doing that as well. If you want me to talk through either the x-intercept or y-intercept, cool. Which one should I do first? Let's do the x-intercept first. So to get the x-intercept, what do you need to do? You need to set y equal to 0. So that means I need to take the equation 0 equals 3x plus 4. I need to solve that for the x-coordinate. So this is a nice situation. It's an equation where there's like only one instance of the variable x. So that just means I need to take everything that's on the side with the x, move it to the other side, and do that in the opposite order that order of operations says we evaluate the right-hand side on. So this I start with x, multiplied by 3, then add 4. So I need to get rid of this 4 first. So what should I do first?
Add 4 on the other side.
Yeah, subtract 4 instead. So subtract 4 to the other side will give you minus 4 equals 3x. Now you need to get rid of that 3. So how do you want to do multiplication by 3? Yeah, divide by 3. So divide both sides by 3. You'll get negative 4 divided by 3 equals x. And all right, that's even what division means. Division is what do you need to multiply x by to get this output. So the y-intercept is at negative 4 over 3, comma, 0. That feel pretty okay? If you want to get the y-intercept, what do you need to do? Well, alternately, how many people in the meantime have already found the y-intercept? Oh, cool. Should I actually talk through finding the y-intercept at all? Cool, let's just see what you got. What is the y-intercept?
4.
Well, you really mean 0, comma 4. Oh, sorry. a y value of ball. And I'll make exactly that same mistake repeatedly. I'll say that the y-intercept is a dumb ball. Cool. And how'd you get that? Well, y-intercepts are generally easy to find. You set x equal to 0, so you'll see y equals 3 times 0 plus 4. Oh, cool. That's already solved for y. You don't need to do any algebra. And now let's see if we can notice a pattern. If you just see something in this form, which intercept does it just automatically tell you without doing anything? Y-intercept. That form was the y-intercept. It was 3 times 0 was 0. It didn't matter what the slope was. In general, this is called the slope-intercept form. M is the slope. B is the y-intercept. To find the x-intercept, you got to do some algebra. Neato. People feel pretty good? So let's see, in the interest of 6 minutes left on the clock, let's do something easy. So here's this one example. So without doing any walk, what is the y-intercept of this line? Yeah, 0 pi. And mainly it's webwalk that'll yell at you for that, right? Should we find the x-intercept? All right. To find the x-intercept, let's set y equal to 0. All right, that looks like an equation we can solve for x. What do we do?
We subtract pi from both sides.
Subtract that pi to the other side, giving me minus pi, because 0 minus pi is minus pi. All right, what next?
Divide by pi.
Divide by pi.
The answer will be -1.
Nice. I might not have the exact decimal value for pi, but whenever I divide a thing by itself, I get 1. Cool. All right. So the next, we'll see what we want to do. With my last 5 minutes, I think I want to introduce 2 new WODs, parallel and perpendicular. So to think about what these WODs mean, let's start with just some pictures. So 2 lines are parallel if they're just like lines in the plane that never cross. But like, there are 2 parallel lines. What can you tell me about their slopes? Identical. They're the same. 2 lines are parallel if and only if the slopes are equal. So that means if I give you 2 lines in slope-intercept form, y equals mx plus b, y equals nx plus d, they're parallel if their slopes are the same. That seem pretty okay? So let's use this to do some things. So find me a line that goes through 1, 1, which is parallel to y equals 3 halves x plus 4. All right, well, let's see, do I know a point on the line? Do I know the slope of the line? Yeah, in fact, what is the slope of this new line going to be?
3/2.
3/2, same as the one I already have. So this new slope is 3/2. I have a point on the line. 1, 1. And right now we have like 2 forms that we might want to put our lines into, point slope form or slope intercept form. Which one seems easier to use right now? I think point slope. We have a point and we have the slope. Let's put it in point slope form. All right, it'll be y minus y coordinate is equal to slope x minus x coordinate of the point. Does that satisfy the prompt? Is it an equation for the line? Yeah. If the problem asks for like slope intercept form, maybe you'd have to do some more work, but it doesn't. All right. Perpendicular lines. So here are two graphs of lines, 3/2 x plus 4 and negative 2/3 x plus 2. Do they look like they meet at a right angle? Yeah, they do. What's the relationship between the slopes of those things?
It's reciprocated over opposite side.
One is negative the reciprocal of the other. So I'll put this in quotes, negative reciprocal. And like, reciprocal is a nice word, but ultimately all that means is one of these lines has slope equal to negative 1 over the slope of the other one. So right, that's all reciprocal means. One is the multiplicative inverse. So let's use that. Do we have time? Yeah. Well, we'll see how we do it. Let's use this to find an equation perpendicular to this through that point. So let's follow the same steps as before. What's the slope of this new line that I want? Negative 2/3. It should be negative the reciprocal of the other. So it will be negative 1 over 3 over 2. And how do you divide by a fraction? You multiply by it, but upside down. All right, so we have the new slope. Do we also have a point on the line? So are we basically done? Yeah. Y minus y0 is equal to slope x minus x0. Feel pretty okay? All right.
If I wanted to, if I come to you during your office hours, could I show you my work for the open-ended problems to see if I'm right?
Absolutely.
Okay.
Yeah.
Is it online?
The quiz will be in person. The thing that is online is a PDF that's some questions to think about.
Okay,
That'll be like, if you can answer those questions, you'll probably set the quiz.
okay, is the quiz tomorrow?
Nope.
When is it?
Friday, next one.
Oh, okay,
I just figured I'd give everyone lots of ample warning that something's happening.
okay,
Homework's due tomorrow.
okay, thank you.
Yeah. Click.